turned on the recording. Now recording. Okay. Let's see. Today is June 25th, 2019. This is the regularly scheduled meeting of ITSC 2309 for summer 2009, not 2309. Little review here. We are in module, what module are we in? Module 6, I believe that is, module 6, joining tables. And we join tables when we are retrieving stuff from one table, more than one table. And up until now, we have discussed the inner join. And so let me go back over the inner join. The inner join, the old syntax of the inner join looks something like this. Select vendor ID, invoice ID, or you can select anything since I'm joining the vendors table and the invoices table. So the vendor and the invoice, it makes no sense really at all to join a table that does not have a foreign key, primary key relationship. And so I can look at some things that I can do to find that out. I can go over to APDB, which is where I'll find these. And if I look at the tables under AP, I can see, I can take a look at the invoices and the vendors table. Now there is some things that I can do here. Under, let's see, it's under I want to see the diagrams. So under tables, I need to pick that out. There's a way that I can see, I can show this set up as views. Where is it? Is it in programmability? No. I'll get that in just a minute, but we can look at it. I can look at this over here, and I can see that under this, under vendors, I have the, under the columns, I can see that I have the vendor ID, and I can see that it is a primary key. Under invoices, columns, I see that I also have a vendor ID, and it says FK, that is a foreign key. And there's other ways to look at that. I can show it graphically also, but I'm gonna follow the foreign key vendor ID and the invoices to the primary key vendor ID. I will usually, and most people will usually, keep these named the same insofar as they can. So when I execute this guy, I'm going to follow this. I'm going to get vendors and invoices, and this is the old syntax. And when I execute this, I'm going to see vendors and invoices. It's going to put them together every possible way, but it will only show me the ones where the vendor IDs are equal. And I threw in here just for fun, I wanted to see where the vendor state and vendor state is equal to CA, because I wanted to show something besides that. I threw in the order by vendor ID, order by the parent key, just so that I will always have the same output. So I'm going to show them to you different ways. If I execute this, I believe what I get, after a while it will log me out. So connect, and if it logs me out, I'll have to execute the use APDB. So from now on, we're going to be using APDB. So let's go try this one. Execute, and I get 39 rows. And the main thing that I wanted to show here on this was that the vendor ID 34 is paired with invoice ID 19. I could show you some other stuff about it. I could show you the vendor name, anything that I had in either table. Vendor ID 34 is also paired with invoice ID 52, and so on. 80, what would I have? 95. Several of them in under vendor ID 95 is paired with six different invoices. But it's only showing me where the state is equal to California. Now, the other thing that I've done here is I've shown this in different ways. What would happen if I change the order of it? Vendor ID, where v.vendor ID. So I have renamed it when I said from vendors. I only have to do this if I don't like typing, because I'm going to have to rewrite this. I'm going to have to say vendors.vendor ID is equal to vendors.invoices.vendor ID. So I'm going to have to retype these tables. So I figure I'm just going to go ahead and name them something short. Up here, I'm going to have to give you, I'm going to have to use in the select line, I'm going to have to use v.vendor ID, because the vendor ID is in both tables. If I failed to put v.vendor ID and I just had this one, notice it gave me a red line there. When I try to execute it, I get ambiguous column name. Anytime you see this error right there, that means that you have a field that is named the same in two tables. So you will have to identify the table. In the select line, I can use something. I can use an alias that I created in the from line, because remember, the from line is executed first. So if I alias it here, I can use it throughout the query, where v.vendor ID is equal to i.vendor ID, and I can use it up here in the select statement. If I invoice it in the select statement, I can use that alias in the order by line, but only there. I would not be able to use it in the where line. Okay, so now I'm going to change the order of it from vendors, invoices. I'm going to say from invoices as I, vendors as V. Still using the old syntax here. And I find out that it doesn't make a bit of difference. They're all the same. So if I execute it again, I still get the same 39 rows. And since I put the order by in there, there is no difference. Now, if I didn't have the order by, it's quite possible that I would get them in a different order. So let's move to the new syntax. I say, as I inner join vendors as V. Notice that the information that you provide is exactly the same, except it just changes. Instead of in the where, we picked up another line and it says on. Some people will indent the on. I'm kind of indifferent to it either way. I'm going to get exactly the same 39 rows. Trust me, they are the same. They are the same query. So the order does not matter. Order doesn't matter. So whether I say invoices inner join vendors, vendors inner join invoices, on v.vendor ID, i.vendor, whether I switch the ons around, it really doesn't matter. And that is it's typical of inner joins. Inner joins, it does not matter the order in which you write the tables. You will only get you'll get the same rows returned if you put an order by in there, and order by the parent table, order by any table actually, you will get exactly the same rows returned. Well, I might have gotten some difference in there with the ordering of them, since I didn't say order by the I, the vendor invoices either. I'm trying to sneeze here. Okay, so there's the other thing about the inner join. Inner join only gives you back records that participate in the relationship. So vendor ID, invoice ID pairs, they have to be in the relationship. But what if I wanted invoice IDs that did not have any invoices? Okay, they don't participate in the relationship. Therefore, an inner join will not show them to us. I can't get it with an inner join. And this brings me to the outer join. Now, the outer join is why we went to the new syntax. I resisted it for a long time. When I was a kid and had to walk to school 2 miles through the snow, this was the way we did a join. And I said, well, that's the way we can just learn how to do the join. And I still start off talking about this one, but I have moved on to the new syntax. It has been our syntax now for almost 30 years now. So I guess it's time for me just to, get out of the Stone Ages and use the new syntax. So the new syntax says vendor ID, invoices as I, inner join vendors as V. The as I and the as V are optional. You don't have to say it. If you don't say it, then you will have to write vendors up here, and vendors.vendor ID is equal to invoices.invoice ID, and I don't like typing. Another thing that you're going to find out, so I may as well tell you, is that if you don't put the inner join there, it works just as well. But I will not be as happy because in this class, I do insist that we learn it the first time, I-N-N, inner join. We're going to learn it as inner join. And later you'll find out that you can skip the inner and you can just say invoices as I, join vendors as V. And my advanced students say, oh, Dr. Smith, just get over it. That's the way people do it. And so I do that. I just get over it for the advanced class. And I say, it's okay. So it doesn't make any difference how the order of things. And the problem with it was that the old syntax was consistent. Where it got inconsistent was on the outer join. Now, the outer join is going to show us all of the records in, and for right now, I'm going to say one of the tables. So it shows us all of the records in some table, one of the tables, and here we're not necessarily restricted to 2 tables. We could have more than 2, but let's just take the simplest case with 2 tables. So I still have vendors and invoices. And notice something about these tables. Vendors as V, invoices as I. One of them is on the left and one of them is on the right. And notice it is a left outer join, or perhaps it is a right outer join. So if I have a left outer join, I say the outer join is pointing left. So I'm pointing at the vendor's table, left. I'm going to see all of the records from the vendor's table and the records from the other table that participate. So if I were to select this, what will I see? If I were to run this query, I'm going to see everything from the vendor's table. So as I execute, notice that I'm seeing, let's see if I can run this up a little bigger. No, I could drop it into Excel, but I don't really feel vendor ID 1 doesn't have any. 2, 3, 4, 5, 6, 7, 8, 9, 10 up through 21 still haven't gotten any. Look at there. When I get to 34, remember up there 34 was the first one. So 34 is paired with 19. So I'm seeing 34 and 19, 34 and 52. And now I'm starting to see a few. So as I go down here, I got mostly nulls, but these are the ones that are null are the ones that are not paired with anyone. So I'm seeing in the output, I'm seeing all of the records from the direction in which the outer join points, all of the records in the vendors table, and the paired records from the invoices table. Important point there. So the order matters. Do I need to see the ones that do not have invoices? Think about the ones that don't have invoices. They're the ones that are null. That do have invoices, since I'm asking about the ones that don't have any invoices, I probably don't want to see the ones that do have invoices. So I have my outer join select the information that I want, and it's not necessarily just the primary key, foreign key. It could be any field in either of the tables. And I point the left join at vendors. There's my join field. Where i.vendor_id is null, in other words, show me only those that do not have invoices. When I execute this, I'm getting all nulls. And is there really any sense in just looking at, excuse me, all of those nulls? Why am I looking at those invoice IDs anyway? Because there aren't any there. So I'm only going to show you the vendor IDs, and I'm just going to leave it to you to understand that if he's in this list, that means he doesn't have any invoices associated. Notice I have 89 rows. So I have more vendors with no vendor IDs than I do that have vendor IDs. The order matters is the bottom line. Let's look at it the other way around. This is a right outer join. And notice that in this one, I have the invoices as I. Right outer join vendors. Notice, so it's invoices and vendors, but the outer join is still pointing to what? The vendors table. So I'm going to get everything from the vendors table because I call it, I say it points. It points to the right. It points to the vendors table. The on really doesn't matter because equality is the same regardless of how you write it. Where again, i.vendor_id is null. I'm going to get the same records from this one as I did. I'm going to get the same 89 records as I did a moment ago. Questions? Pause for a minute.
So is there really a need for right and left?
Good question. Is there a need for right and left? In fact, some platforms only give you one of them. I don't think there are any production platforms out there today that don't give you all of them, don't give you both of them. We have a right and a left, and we also have a full outer join and in SQL Server, which gives us everything from both tables. We typically don't use that one very much, and I don't usually cover it. So I'm going to cover the right outer join and the left outer join. I would be just as happy if I only had one of them. I don't have to have both of them since I can just switch it around. When you get more than two tables in there, it can get kind of tedious having to keep track of it all. So it gets a whole lot easier if you have both the left and the right. But for right now, it points one way or the other. Similarly to the inner join, if you don't write outer, if you just say right join, you get the same output, but you don't make as good of a grade. To make my point. So, and here we are going to say right outer join, left outer join or inner join. So we will never write join without having outer or inner come before it. Notice it is just one T. My favorite misspelling is to put a double T in it. And then I wonder why I get the error. And okay, so you use the outer join typically to find childless parents. That outer join is the only way I can find childless parents. Now, if I take the output from both tables, I find not only childless parents, but also childless also parents with children. So if I don't constrain it as on line 57, where I say where i.vendor ID is null, if I take this out, now I will see all of the records. So now I'm seeing records from everyone who participates and everyone who does not, and vendor IDs that have no children. So I see all of the vendor IDs, whether they have children or not, and I see the vendor IDs duplicated that have children. For example, I see 37 a triplicate of 37 because there are 3 invoice IDs associated with 37. Rest of them are all singular. I get a total of 202 rows. By the way, I've thrown some errors into this, and some people have noticed that that their output in the first part was a little bit different by about 1, and we'll see why that is in just a moment, than my output. I'm trying to get those fixed. Okay, find childless parents. Point the outer join at the parents. Now here's the deal. Are there any invalid children? And yes, in fact, there are. And that's why you're getting a weird one in, I think I changed one of the keys where it should have stopped me from doing it, but because I'm the supervisor, I can do anything I want to do it to me. I should. But I went in and deliberately put an invalid child in there. So there's one child in that table that has an invalid parent. Anybody see that one? If you noticed, you're off by 1, and you're getting 1 extra record, I believe. It doesn't participate in the inner join. You can't find him in the inner join, and this is the problem. So now to find invalid children, you'll run across this problem will manifest itself when you are taking over a database from somebody and they have not correctly set up the foreign key relationship. They didn't put the foreign key constraint in, or they disabled the foreign key constraint. And sometimes if you are doing a batch insert, it is a lot faster to insert. If I'm inserting 2 or 3 million rows, and I don't want it to take all night, I just want it to go. I'm willing to accept the fact that there might be errors in there. Sometimes it'll go a lot faster if you will go in and turn off the foreign key constraint. Why? Because if I insert something and I have a foreign key, that means I have to search that table to make sure that the foreign key exists in the parent table. What if I say, okay, I'm willing to take it if it's wrong, and I'll find it later. Okay, it's time to go find it. So that's what happened here. And they tried to turn on the foreign key and to check them and make sure that everything was fine. And it told them right away that everything wasn't fine. We'll talk about that. We'll have a module where we do that a lot. Right now, we're just going to find it. So notice that I'm pointing the outer join at the child table. So the invoices is the child. One vendor has many 0 or more invoices. So invoices child, so that the outer join points at the child. Now, this is going to show all of the invoices, and this one will also show the vendors that participate. When I execute this, it just so happens that since we're ordering by vendor ID, the vendor ID comes to the very top. If it didn't have that order by vendor ID, he'd be somewhere down in there. But there's my null one right there. Vendor ID is null, but the invoice ID is 68. What is this? So I'm finding they're participating in the relationship, but they have a bad parent ID. Okay, so this vendor ID is bogus. Well, let's go take a little closer look at it. Let's drill down onto it. And first thing I'm going to do, I'm going to get rid of all of these other vendor IDs, and I only want to see those invalid ones. And I find out that I only have one of them. Oh, that's good. I only have one I have to fix. Are you with me? Okay. Let's drill down a little more onto it. And I'm going to say select vendor ID, invoice ID. So, okay, I want to see I.vendor ID. Now notice this one up here, I was wanting to see the V, the vendors.vendor ID. So this one is going to show me null. And this next one is a little bit different. I want to see what's actually in the table. So this is going to show me the bad data in the table. I could still leave this one in there, but I'm going to see this one with the bad data. It's going to show me everything I need to see. And I'm going to see that the bogus vendor ID is 999. There's no such vendor. And the invoice ID is 68. Now, if I'd had those constraints set and I didn't go in and turn it off, it would have stopped me from putting that in there. The whole idea is to stop people from putting it in. If you're the owner of the database, yeah, you can do about anything you want to do. You can turn those constraints off. It is a poor idea to do it. Now, what do I do with this record? I can see, let's see, R. I can see anything. Let's take a look at it. I want to see all of the records, all of the fields that are there. So I could say select from the vendors table, I want to see all fields. And from the invoice, I want to see all fields. I probably should say here, I guess it will let me say I dot everything. So show me everything from invoices, everything from vendors. Let's see what all I have in there. Most everything there isn't. From vendors, I'm not getting anything. From the invoice ID, I can see that I have invoice ID. There's my bad datum right there. Invoice number, invoice date, invoice total, payment, and I have all this stuff there, a credit total, terms ID, all of this good stuff. What do I do with that stuff? I'm trying to fix this guy. What do you think I should do? I'm the database administrator. And I find this, I'm checking to make sure that the data are all good. So I go in and I look for childless parents, but that's okay. Childless parents don't bother me. That's just something that's going to happen. But if I have a child with a bogus parent, that's a problem. And I have a database consistency problem. What could I do? Yes, I'm looking for some feedback.
Hey, I'm sorry. I'm having trouble figuring out how to correct it because I'm a little stuck. I mean, I stuck on how it occurred.
Oh,
I expected, based upon what we said. I mean, I understand that when you're dumping tables, you say, "Hey, I'm going to pull out. I'm going to comment out all the constraints because I want to do my data move all at once and go to
hmm
sleep and not have to do, you know, the parents first, the children next, blah blah blah." But I expected to see that you had, I guess I didn't expect that you would find vendor ID to be of actual value in the invoice table and be null. I expected it to be the reverse. I expected to see the value in the vendor table and a null in the invoice. And so now I'm just a
okay.
little confused. So maybe I'm
Uh,
not the only one.
so if I had let's say I had a null here under vendor ID, right? Is that what you're asking?
Right.
That would
That
just be
would mean
that's an orphan.
right, and that would mean that you remove, whoever did it removed the constraint that the foreign key, which is the primary key from another table,
Right.
not be null.
Yes, and that's an external constraint that somebody put on that table, or that I did actually. But we put it on there because we don't want orphans in there. But orphans in and of themselves. Now, maybe with your business model, you don't want orphans. That's okay. Let's say I'm running a veterinary clinic. And do I really want a dog in my database that does not have an owner?
Mm-hmm. Sure.
Probably not. Uh, so,
No, I mean
uh,
I'm with you.
okay, so I constrain it and I say no orphans, and so I write the constraint onto that table, and I say that the check that the invoice under the invoices, it says check that invoices.vendor ID is not null. Okay. The other one says it's a foreign key references. It says it references vendors.vendor ID, and that would block it. That would stop it flat in its tracks. Okay. Now you ask me, how could this happen? Um, well, it's fairly simple actually, and since you ask, I'll cover it. Um, it's like this: alter table. Let's see, that's in the invoices table. Invoices, no check. No check. I believe the constraint, and here's where I need to know the constraint name. So I would go over to my Object Explorer, and under the invoices table, under constraints, invoice number, keys, under keys, invoices, vendors, foreign key. So there's the name of the constraint, and copy. Let's see, it's one word? Yeah, no check. And so I get the right there, alter table invoices, no check. In other words, turn it off. I don't know how I got that carried here. So if I execute this, it turns it off. Now the constraint's still there. When I turn it back on, it will not go recheck everything that I did. So I can turn it off right here. I can just say execute, and notice it's successful. That constraint is gone. That constraint is no longer there. If I when I want to turn it back on, it's fairly simple. Instead of no check, it is now check. So I turn it back on. Now it's going to check. Okay, if I want to turn it on, alter table invoices, check, alter table invoices, check constraint. Let's see, where does it go? Right here, with check, check constraint. So notice it's got check, check there together. That always looks kind of strange to me when I don't put it on a separate line. And I'm expecting this one to fail. And yes, it did. And this one failed when I tried to turn it on with check. Alter table statement conflicted with foreign key constraint. And this tells me that I got a problem. Okay, so what I'm saying to do, since you brought this up, this is really from a little bit farther along in this class. So I'm not reaching into another class. We're going to talk about this. This one, alter the table invoices, turn it off. This one says alter table invoices, turn it back on. But if I turn it back on, I don't check the existing data. Are you with me, Tracy?
Yes.
If I say alter table invoices with check, turn it on, that says go back and check all of the existing data. So this was the one that failed. So I can turn it on, not a problem. That's successful. So I can turn it off, turn it on, and that's how you get bad data in your database.
Oh, okay. Thank you. And, you know, because I guess the other thing was I was thinking that it happened because someone not only turned off the constraint, but say the 999 is invalid as a vendor ID. Is it invalid, or was it a valid vendor ID that someone accidentally deleted?
They would have had to have turned off the constraint to have accidentally deleted it. So the constraint will stop them from inserting it into the invoices table, and the constraint will also stop them from deleting it from the vendors table if it's there. You know, it got there legally. So the constraint will really protect you. And it's bad luck to turn off your constraints in general in a production table. You don't. That's something you almost never do. You just go ahead and eat the cost, the extra overhead of doing a big batch insert. And some people will turn it off. They turn off constraints on, let's see, what is census day at the college? I mean, I'm not saying when. We don't. What does it mean for us to have census day on the 12th class day? We just had it last week, where you get dropped if you're not attending, right? Okay. What does it mean? Well, it means that now you're in class. It's a database thing. They go in and they turn on all of the constraints and they check all of their tables, because what's everybody doing before that? They're jumping around from one class to another. They're inserting stuff. They're deleting stuff. They're doing all kinds of jumping around from class to class. On the 12th class day, you're in the class. Nobody moves after that. That's where they turn on all the constraints.
Oh, okay. I would have thought they did that by the third day when they don't allow you to sign up to audit or anything else like that. I would have thought it happened earlier.
It might happen earlier. We're going to talk about indexes, and it's more of an indexing thing. But think of it as a constraint. So the constraint is a unique, the constraint demands that value be in the other table. So if you're going to insert something into the invoices table, it has to go search the vendors table also. Now, if you turn that constraint off, it doesn't have to do that. But you can also get bogus data in there.
Got it. Thank you.
Okay, back to my question. What are we going to do with it? And the answer is, I don't know. What are my options?
Well, like I said,
Go ahead.
Don't you have to figure out if vendor ID 999 is legit if it was deleted or if it was incorrectly added?
I know that it is not legitimate because I trust my outer join. My outer join is telling me that I've got a 999 in there, but that I do not have a corresponding 999 record in the vendors table, and that makes it bogus.
But I mean, to fix it, one fix might be that you needed to add vendor 999 in your vendor table.
Okay.
So I'm saying, how do you know?
Yeah.
See what I'm saying?
I hear you. Maybe I can, maybe I can't. So one way to fix it is I could have a field. First thing I would have is a table called errata, where I'm going to park something. Just if I don't have a clue what to do with it, I'm going to copy it to the errata table so I do not lose the data. Okay, and it'll pick up another key in there. I'll have I'll timestamp it or something, such that I can go back and find it. The other thing that I would do, I would probably have in my vendors table, I would probably insert a record in there, and I would call that record the parent of orphans. He even has a name. He's called Poo, P-O-O, parent of orphans. And if I have an orphan invoice ID, an invoice ID that is null, I don't want it to be null. I don't know to whom it belongs. It's just sitting there. It's not hurting anything, but that's the one that picks it up. So now I don't have any nulls in my invoices table. And I would do something like that with that 999. I would change it to something that's valid. And so the parent of errors or something like that, I would give him that, maybe it's a -1. That value that says, I don't know what to do with this, so I'm going to give it, I have a parent that picks up these records that I don't know what to do with them, but I don't want to just delete them. Sure as I do, they're going to be important. Make sense? Okay. Anyway, that's what I do with it. Okay. Now, let me see if the two biggies for, okay, so in this particular topic, we have talked about inner join. Inner join is fairly simple. Inner join follows a primary key to its, or follows a foreign key to its primary key and gives you the pairs. You are not limited to two tables. I can have as many tables using the old syntax. By the way, this is the syntax. This is called the implicit join, where you just say vendors as V, invoices as I. What else do we have in there? Oh, there's other stuff in there. Let's see, columns, terms. So for example, the terms ID, I believe is referenced invoices. So the terms ID is a foreign key. So I can follow the terms through the invoices to the vendors. And I can have as many as I want. What I usually do if I'm using the older syntax, I actually like it a little bit better. I just put them in there. I start at one end and put them in there. So I put in the vendors, comma, invoices, comma, terms, and then I just start linking them together. And I start at one side and link these two. And then I take the next one, say the invoices and the terms, and I link those two with an and. And when I get finished, so it's fairly simple. This one gets a little trickier when we're down here and we have inner join. So I select this, so I have from invoices, inner join vendors on this, inner join terms, so that would be this inner join terms on, and then link that one. but you can have as many as you want. Most of the time, with an outer join, most of the time, not all of the time, but most of it, there'll be 2. Because it kind of tends to get a little tedious when you get more than that, but it's quite possible to have a single SQL statement that takes up 3 pages of code. So you use an outer join to find records that do not participate in the relationship usually. So that is to find childless parents. Well, childless parents aren't really much of a problem, but the only way I have of finding them is with an outer join. And the other one, finding invalid children. Okay. How would you find orphans? Do I have any orphans in the invoices table? How would I know?
Isn't that
go ahead.
Isn't that as simple as knowing what your foreign key is in your table and then searching for any time the foreign key is null?
Exactly. And that's typically a test question I ask from select something. I don't do the asterisk very often. Sometimes I will in this case select and then from invoices. I don't believe I do where vendor. Okay, so it'd be this. I only have to look at one table to tell that. I don't think I have any. 0 rows, so I don't have any. I got to put an orphan in there just to have something to find. Okay, so for finding childless parents and children with invalid parents is the idea. Okay, let me go over here and see if I have outer join, unmatched foreign keys. Okay, so unmatched foreign keys, this is see what that is. Okay, oh, here's the no check constraints, and here that's how you turn it off and then turn it back on. And I say that it would produce an error because the data will not satisfy the constraint, but you have to say alter table child. You have to put a with check in there to cause it to throw the error. So this one, child issues, I'm talking about, so what do we do now? There's three options I'm going to have. I cannot leave inconsistent data in the table. I would insert the offending rows into an errata table and just delete them from the child table. In other words, move them. If the other constraints allowed, I could set the foreign key to null unless it's constrained against it. I probably am if I built it. And that's where we insert the record called the parent of orphans. And so if I insert that into parent, I put this one, I put that foreign key into the parent table, and now I can update it. By the way, this is a subselect statement. And we're going to talk about that next. Be careful when you update. Database has an undo capacity similar to that of an M16. It might be offensive in today's world. Okay, so we don't we have to be very, very careful with our database, because yes, we can back it up, yes, um, but a restore operation can easily shut that database down for several hours. And if you have to restore a large database from a tape backup, and it's what's known as a resume generating moment, because it's not as simple as just pressing an undo. Database is written directly to the disk. And finding childless parents, again, unmatched records, talking about, I'm not going to read it to you. Okay, this is the outer join assignment. That is now 6:50. What I'm going to do now, I'm going to end the assignment, and I'm going to have a lab period, and then I've noticed some students are struggling in the creating tables. Apparently we didn't get well across. So I'm going to go back over that and go through the examples again. So I'm going to make another recording for that, and then I'm going to make a brief 10-minute recording of this where I just hit the high points. So I'm going to end the recording now. Let's see. So there's my little dot. Okay.
Well, no, I actually think that answered it. That right now we need to just sort of, we should be learning the basics and structure, and not veer a lot from that. So that answered.
And some things I'm not doing deliberately. For example, your idea of the primary key that automatically increments. Okay, so in Access you would call that, well, what would you call that? Auto number, I think. In SQL Server you call that an identity, and it automatically increments. So as you as you insert a new record, it starts off with 1 and then gives you 2, 3, 4, 5, and so on like that. I am not a big fan of those. I like to control what is in my database, and I don't like ceding that control. Now, if I want if I want to get a primary key, probably I would use a timestamp. So I just, and I knew that they would be coming in over a millisecond apart, then I just timestamp it and use that as the primary key. But you can have a counter that runs most of the time, your users are going to be interacting with the database through a web page. So I've got a lot of programming between the user and the database. So I can fairly easily create a primary key that is unique from within the web page. I mean, that's something a web page can do, and just pass it on into the database. But the database can do it, and just instead of making it an integer or a varchar or something, you make the primary key an identity, and it will count. If you look at the create AP DB, it has identities in it.
Yeah.
Yeah. Others. Okay, what I'm going to do is I'm going to bounce the system right now. And by that, I mean I'm going to take down Zoom, and I'm going to restart it immediately. So if you want to ask any questions or anything, you can just log right back in. I have to bounce Zoom, shut it down, and bring it back up before it will. It'll start processing the file so that I can upload the file to Canvas. So I'm going to do that now if there are no more questions on this particular stuff. And then I'm going to Go ahead. Somebody's talking.
Oh, I was just saying thank you.
You're welcome. Anybody else? Speak now or bounce. Somebody's chatting with me. From Larry to everyone. Yay. Okay. Well, I'm going to bounce. I'm going to, in about 2 seconds, I'll be back in just a second. But for right now, you're about to end.